A very good morning to one and all. Assalamu alaikum warahmatullahi wabarakatuh. So, dear students, as you all remember, we were talking about the first chapter in chemistry, that is chemical bonding. And you all have submitted your notes, but it was I have already told you to just pick out what all are the chemicals you see in your kitchen, in your home. But three of you have submitted and all three just copied it from the net. So please restrain from copying. These are the simple activities which you enjoy, and more you understand what is happening between these the different elements, and how are different compounds are forming, and how can we use them. So please make sure that make chemistry interesting. It's neither like a history, nor is a mystery, nor is a pastry that you eat. It has got very good, ways and means by which you can understand. You can understand the chemistry inside yourself. You can understand what are the elements or the compounds that are used in making drugs, and in what all are the places we are able to use these chemical compounds, atoms, and elements. Like, as you all know, that water is an element. Water is also a molecule which has formed because of hydrogen, combination of hydrogen and oxygen. So let us see. Today's chapter we are going to know about how is this chemical bonding happening, and what is the reason behind, what are unstable elements and what are stable elements. There are sort of inert stable elements जिसको किसी से combine होने की जरूरत ही नहीं है. They are stable in themselves. लेकिन थोड़े elements they are not stable. उनको कंबाइन होके कंपाउंड्स फॉर्म करना जरूरी होता है. तो हाउ इज इट हैपनिंग, एंड व्हाट इज द रीजन, व्हाट इज ऑक्टेट रूल, एंड what is valencies, what is nucleus, what are electrons. These are all, आपको दिखने में लगेगा बहुत ही कॉम्प्लेक्स कोई चीज़ है, लेकिन ये बहुत आसान है. थोड़ा ध्यान से देखिए. अगर समझ में नहीं आ रहा है तो we can repeat it, but please don't copy. Copying is not going to help. After this session, I'm going to conduct your online test again through Google form to test how much you have understood. So this assessment is only to know your understanding. And believe me, once you start understanding, you would love chemistry. So please make sure, concentrate more on understanding. So let's go and see how are we going to. I'm going to share this chemical bonding with you all. Let's see how to get to know it, right? So you would see this screen. So now the bond, we have already learned about different elements that are present, and how has why Mendeleev periodic table has become so popular. वो इसीलिए popular हो गया कि he has arranged all elements. जैसे कि आपने biology में पढ़ा है, how the father of biology, Aristotle, has divided all animals into various groups and families. So also Mendeleev has divided all these elements, 115 elements, in a periodic table according to their properties, उनका nature, उनका characteristics के हिसाब से. So let us see कि why do these elements combine together? Like sodium is an element, chloride is an element. Why do they combine together, and what happens when they combine? जब sodium and chloride combine हुआ है तो sodium chloride form हुआ है. That's a common salt जो हम लोग everyday use कर रहे. Our body needs this common salt, and there are so many nutrients that are required. तो इनके combination से भी हमको बहुत सारे फायदे होते हैं. और there is a force of attraction and repulsion. अगर attraction, force of attraction, as you know, I mean, you have already done it in your lower classes, the force of attraction of a magnet on the south pole and north pole. अगर if the same poles are brought nearer each other, positive, they repel. and negative also repel. But when positive and negative come together, they attract. So what happens in these elements is, if the force of attraction is more than the force of repulsion, then they form a compound. Okay, so let us see how is it happening. So this is how I have given you a example of sodium and chlorine. Sodium and chlorine are, sodium is positively charged and chlorine is negatively charged. So then naturally, they are, these positive and negatively charged electrons will attract each other and form a very strong bond. And when you shake salt from a shaker, the sodium and chlorine atoms are being held together. That is what has happened. You cannot separate them once this compound is formed. You take a salt bottle, shake it, do whatever, but you cannot separate them. They are so firmly held together. It is because of their opposite charges. And then, what are we doing is, you can do these experiments at home and see, is it possible, can you do that? Then these electrons, this force of attraction of the nucleus to the other atoms, you can see that there is in between you, let me use the pen and show you how is it happening. So you can see that, you can see an orbits. These are all the imaginary orbits that are revolving around these orbits, and are inside it. You can see this is called as a nucleus. Okay, so this nucleus is positively charged, and all the electrons around it that are revolving are negatively charged. So this negative and positive charge is responsible for keeping this bounce stable. Okay, so they do not they do not go and fall into the nucleus. The distance that has been maintained with the positive and negative charge, the repulsion and attraction, the force of repulsion and attraction makes them maintain their boundaries. So let us see how it is happening. Okay, so this you can see that electrons are always negatively charged, and positively, these electrons that are negatively charged, they repel each other, and positively charged nuclei also repel each other. So if the strength, as I told you, the strength of attraction or repulsion will decide the type of bound. And we do have a types of chemical bonds also, which we are going to do it in the next class. But right now, you just understand repulsion and attraction. Repulsion, they move away from each other, and in attraction, they get attracted to each other. The nucleus and the electrons in the innermost shell remain unaffected when the atoms are revolving. So when you see that electrons in the outermost shell, what is valency? This is a very common question. Most of the time it's asked in your exams or the tests, essays. So valencies, there, these all, most of these words that are being used are Greek and Latin. कोई ऐसी बड़ी चीज नहीं है, उसको समझ जाना है. Valency आते ही बच्चे परेशान हो जाते हैं. How to write? You keep on rote learning, by hearting. Don't do that. Just remember, valency is the combining capacity of a element. The outermost shell, ये जो बिल्कुल बाहर के shell में जो electrons होते हैं, they tend to attract each other. So ये बाहर वाले shells, they attract and form a bound. So ये bounding is also very interesting. We will be learning it in the next lesson. So depending upon the valence shell जो आखिर वाला जो shell होता है, उसकी capacity के हिसाब से your bounds are made. So let us see the electron and valence electrons are responsible for the formation of bonds between the atoms. As I told you, sodium is positively charged and chlorine is negatively charged. You can even see a small charges over it. And now comes the periodic table. So Mendeleev has so beautifully made this periodic table. Depending upon, that's the reason after so many centuries of his death also, we do remember and follow his periodic table. So you have studied the periodic table in your, from class 8, you are studying periodic table, and how are all these elements so wonderfully been, placed into it. Some of them are very reactive, some are less reactive, and some do not react at all. Like if you see the inert gases like helium, neon, argon, krypton, xenon, and radon, they do not, they are called as the noble gases. Neither they lose their electrons nor they attract any electrons. They are stable and they need not form any bonds. So what is happening is, say some electrons are more, and what could be the reason for the change in the reactivity of the elements is very important. You have to understand what is that is making the electrons react. So in periodic table, you can see the arrangement of the elements in the periodic table is according to the electronic configuration. That gave a new thought about the chemical bonding. Again, electronic configuration, don't get confused with such big terminologies and the words coming. Configuration, what is it? It's very easy, and we are going to explain you. I'm going to explain you कि electronic configuration आखिर होता क्या है. Okay. So you have seen that these are called periods. Okay, in this, let me again tell you what are periods and the groups. These are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. These all are periods of a periodic table. And groups, when you come down, you find all groups. So the periodic table is divided into 18 periods and 7 groups. So what happens to the elements in a group and what happens to these elements across a period is also a very interesting phenomenon which you are going to observe. So periodic classification and the arrangement of the elements in the periodic table according to the electronic configuration, it has given a new thought about chemical bonding. Once एक बार आप समझ जाएंगे कि ये कॉन्फ़िगरेशन में कैसे फॉर्म होता है, वैलेंसी क्या है, इलेक्ट्रॉन कॉन्फ़िगरेशन क्या होता है, व्हाट आर पॉजिटिवली चार्ज्ड एलिमेंट्स, व्हाट आर नेगेटिवली चार्ज्ड एलिमेंट्स, तो केमिकल बाउंडिंग समझना आपके लिए बहुत आसान हो जाएगा. So let us see what are noble gases. As I told you, this 18th, you have got this 18th group. ये जो 18th group है उसमें you see that these are called as a zero group or the inert gases. So these typical gases have got negligible chemical activity. They are stable, they don't need to react with any other element. So that is the reason we call them as noble gases or inactive gases. It's very difficult to make them react. Okay. So these are inert or noble gases. And how did they become noble? Because of these noble gases, the octet rule has come into existence. So let us see how are these elements combining with each other. And you see that typical, please go through the periodic table again and again and see how they undergo few or no chemical changes. Or you may come out with some of them which may not be arranged in right place. It would be great if you can search and tell me which are those elements which are not supposed to, according to the rule, they were not supposed to be in the position, but they have been placed. Can you identify and find it out? That would be one of the question for you to complete it and get your marks for performance marks. So you can just see how is this electronic configuration taking place. Every element has got electronic configuration. They have got different shells. There are 5 shells, and we say Z shell, K shell, L shell, M shell, and N shell. So let us see how are these shells of an electron in an element are arranged. If you look at an element, and what are the valencies? Okay, what do you mean by a valence electrons? If you look at helium, helium has got 2 electrons in Z shell, 2 electrons in K shell, and the valency is also 2. That means it has got only 2 electrons. And neon has got 10 in Z shell, 2 in K shell, and 8 in L shell. And valency is also 8. It can either lose or gain 8 electrons to become stable. And then argon, you see 18. It has got 18 in Z shell, and Z shell, 2 in K, 8 in L, and 8 in M. And the valence electrons are again 8. And similarly, krypton is 36, 2, 8, 18, 8, and again the valence electron is 8. So what is, look at the second column and third column. If you look at the second column and third column, what do you find? It's clear that all noble gases have got 8 electrons in the outermost shell except helium. If you look, helium has got only 2. But if you look at neon, argon, and krypton, all of them have got 8 electrons in their outermost shell. That means they are very stable and they do not require, they cannot gain 8, okay, or they neither can they lose all 8. So that's the reason they are stable. So now what you have understood is, you understood what are elements, then you understood what are compounds when they combine together to form compounds, molecules, understand the difference between compounds, molecules, elements, electronic configuration, and valencies. This is very important to understand how chemical bonding takes place. And the position of the elements in Mendeleev's periodic table is very important. Now, let's see what exactly is happening here by the Lewis was another scientist who has given this. According to him, the arrangement of the electrons in the different shells that contributes to the electronic configuration of 18th group element is shown in table 1 here. So this is an 18th group element where these are all noble gases. So we have just seen that valence electrons are in the outermost shell. So how many electrons do they have in their outermost shell? And we have seen that helium has got 2, neon 8, argon 8, and krypton 8 again. So then this is the typical phenomenon because of which these elements are in the 18th group. So now you see the valence electrons in the atoms of an element are depicted in the short form by Lewis symbol. And we represent the nucleus and the inner shells of the electrons by a symbol of an element, an electron in the out shell by dots or cross marks. So Lewis had used a way by which dots around to express either this is explain the symbols used to show the outermost electron is in the form of a dots, which Lewis has used it as a symbol to show that calcium has got only 1, it doesn't have, whereas fluorine has got 8 outermost into it. So, and cross mark, either cross marks, what we represent is nucleus and inner shell electrons of the atoms by a symbol of an element, and electron in the outer shell by dots or cross marks. So how many electrons are present in the outermost shell? Like you have seen, calcium has got only 1. So he has denoted it by a cross mark or a dots. So either it may be represented, if you may get it in simple questions in your multiple choice of the blanks where CA, a cross is given. What do you understand by it? So that means it has got only 1 electron in its outermost shell. And that is how CaF2 is formed. How does Lewis dot structure of argon and sodium atoms are written? Let us see. In argon, you see that there are 8 outermost electrons. And whereas in sodium, how many have you seen? So the first you are writing a symbol as AR, and then the black dots donates that the valence electrons around the symbol. So these are the valence, the outermost valency electrons that could either share. This outermost shell are the valency electrons. So when it has to combine with any other element, either it has to lose electrons or gain electrons depending upon the I should say the power of attraction or repulsion. Which one is more? Based upon that, an element may lose or gain electrons in its outermost shells, and they try to become stable and inert like noble gases. So let us put two dots at them, four sides of a symbol, and so what do we get? So what are we getting? Like sodium. In sodium, what do you see? There is only one valence electron. And how do we know that whether it is positively charged or a negatively charged? Is again, go through and find out how do you know that sodium is positively charged. Whenever there is a tendency of an element that has got a tendency of losing is positively charged, and the element that has a tendency of gaining electrons is negatively charged. तो ये आपका माइनस और प्लस नहीं होता है जो मैथमेटिक्स के मल्टीप्लिकेशन में करते हैं. मोस्ट ऑफ द टाइम स्टूडेंट्स गेट कंफ्यूज. दे थिंक दैट अगर पॉजिटिवली चार्ज है तो इट इज गेनिंग, उसके पास इलेक्ट्रॉन ज्यादा, इट कैन गेन, and when it is negatively charged it is losing, but it's vice versa here. If an element is positively charged, that means it's losing electron, and the negatively charged is gaining electrons. Okay, so remember this. So we can also use a cross mark for the electrons, and if you see at the list, structure of sodium atom is therefore where sodium has got you can just see how is this neon and argon, how the electrons arranged around them. These are the noble gases, and they are found in which group? They are found in 18th group. And Davies' experiment in 1778, in the 17th century, he was a professor of chemistry in the Royal Institute of London. He constructed a battery, metallic battery of 250 metals. And what was his experiment actually? He wanted to show that how are they highly reactive, reactivity of the metals like potassium, sodium, and by fused salts. You have already learned the electrolysis of water, in which we are using cathode and anodes to separate hydrogen and oxygen. How are we making electrolysis? We are dividing it, we are breaking it down into the negatively and positively charged. So similarly, he has used this experiment to see how potassium and like potassium, sodium, what happens when these salts are fused together. So through this experiment, what has he done? He used the metal part. He has seen that some of the parts are migrating towards negative electrodes and some are migrating towards positive electrodes. So the negative ones will move towards positive ones, and the positive ones will get attracted towards the negative electrons. So this way he could conclude that metals are negatively charged and non-metals move towards positively charged. So metals have to be positively charged, then only they'll move towards negative electrodes, and non-metals are negatively charged. That's the reason they choose to move towards positive electrodes. So that is how through this experiment he has shown. As I told you, how can we say that sodium is positively charged and chlorine is negatively charged? So Davies has helped us in finding out whether an element is positively charged or negatively charged. So hope this is clear to you all. So he proposed that all metals are responsible for positively charged particles, and non-metals are responsible for negatively charged particles. So let's go back to chemical bonding now. These oppositely charged particles, they are held together by an electrostatic force in a compound. So as I told you, this sodium chloride is a very strong compound. As I told you, if you keep shaking a bottle also, you will not be able to separate sodium and chloride because of this strong bond. And this bond is being formed by a force called electrostatic force. forces also you have learned about the types of forces in your class 8. So you do remember this electrostatic. What is the electrostatic force of attraction? The electrical attraction, that is the cathode and anode, or negative or positively charged. And hope, do you agree with this explanation? And if you have agreed, why did you agree to this explanation? Like you do in your science fair projects, there's your hypothesis. So does your hypothesis being got accepted or rejected? So he has even, Davy has shown evidentially how can he prove his hypothesis. So you can see that while this explanation could explain the bounding in sodium chloride and potassium chloride, you see this is sodium and potassium. It could not explain the bonding in carbon compounds or diatomic molecules of elements. Like there are some of the atoms, like oxygen, combines with its own. Some of them combines with its own elements, forming diatoms like oxygen O2. uh, this carbon compounds or diatomic molecules of an element, they combine. So he did we can just do an activity to see. You see group number, what is valence electron, and this Lewis dot structure. Hydrogen is 1. So its valence it has got only one electron in its outermost shell, and Lewis dot has shown it like this with having one dot. So you can see that if you see Lewis dot structure, you can explain it that hydrogen is got only one valence electron in its outermost shell, and one electron means it belongs to which group? Group number 1. And if you look at helium has got 2 valence electrons, and it belongs to 0 or inert gas, noble gas group. And beryllium has got 2 electrons in its outermost shell valence, so it has to be. Depending upon that, you can easily, when you see a beryllium, you should know that beryllium belongs to which group? Group number 2, because it has got 2 dots on it. That means it has got 2 outermost electrons in its shell. And then if you look at boron, it has got 3 electrons in its outermost shell, and it belongs to group 3. And carbon has got 4, and it belongs to group 4. Similarly, nitrogen has got 5, so you can check it into the periodic table, it belongs to group 5. And similarly, oxygen in group 6. So beautifully, Mendeleev has, based upon their characteristic reactivity, rate of reactivity, and charges, it has been divided into different groups. It also, consults that the periodic table and fill in the group number of the elements also consult. Okay, you just check in the periodic table where do they all lie. So you see the elements like hydrogen, helium, beryllium, boron, carbon, nitrogen, and oxygen, and their group numbers are again being given to you to understand that hydrogen belongs to group 1, helium belongs to group 0, beryllium group 2, boron group 3, carbon group 4, nitrogen group 5, and oxygen group 6. And the valence outermost electrons depends upon the number of in the group they are. If oxygen is in group 6, the valence electrons that are present in oxygen are 6. And these dots denoted by Lewis also shows the same. Please open your periodic table and check out, are these elements present in it or not. And whenever you see an element in the group, then that means that is the valency. If you remember periodic table very well, where all these are arranged, so you'll be able to understand what is the valency of that element, the combining capacity of that element. We can see the relationship between the number of valence electrons and the group numbers. So you have seen that the valence electrons and group numbers have, the relationship is same. Whichever the group number, in group number that element is, it is what is its valency. So we find that from group 1 to 2 and 13 to 18, we can use the periodic table to find the number of valence electrons. If an element is in group 18, that means it has got 18 valence electrons in it. So group 1 has 1 outermost electron, group 2 has 2, group 13 has 3, and so on. And 18, group 18, sorry, I said group 18 doesn't have 18 electrons, it has got 8 valence electrons that are our inert gases or the noble gases. So it was found that the elements which participate in chemical reactions get octet or NS2-NP6 configuration, similar to that of the noble gas elements. So let us see this configuration in our next class. Till then, be prepared for your assessment that would have that I will be taking in your next bio class. Till then, be prepared, be safe, be inside your homes, don't go out, use mask, social distancing, and then be safe, remain safe. See you all. Bye bye. Allah Hafiz.